So in the previous lecture, we got this mass of unstructured text that we scraped from a city's website. Here we're going to try and do something with that text to make it more systematic. So for example, extract the number of parking spaces. That makes it easier to analyze rather than reading through thousands of description fields. So let's start by loading the data that we saved at the previous lecture. And we can read a pandas data frame using this read pickled function. We saved it as a pickle, we used toPickle, so we'll read it back using read pickle. If we'd saved it as a CSV file, we'd use read CSV instead. So we'll get back what we started with, or what we ended with in the previous lecture. So we've already scraped the description for each project. But suppose we want to extract a particular piece of information. For example, how do we get the number of parking spaces? Well, this is going to be some more detective work, and we're going to need to look and see if the city uses consistent terminology. So you're going to need to design a set of rules that cover lots of different possibilities, whether the description says 2 parking spaces, or they're shouting at you 2 parking spaces, or if they're saying 1 uncovered and 1 covered parking space. So you need to just look at your data to see how it is structured, like what are the key reference words that you're going to want to look for. So let's start with the simplest case. And we're going to add a column to our data frame that indicates whether there is no parking, the string, no parking, in the project description. So let's use the NumPy library, and this is an array library that underlies the magic of what happens in pandas. And it has an NaN, or null value, which indicates missing data, which we're going to make use of. So we're going to create a function. We're going to pass to this function, the argument is going to be this description text. This is what we extracted from each permit web page in the previous lecture. We're going to make our life easier by converting it to lowercase, so we don't have to look at different possibilities if parking is in uppercase or the first letter is uppercase and so on. We only have to look for parking in lowercase letters rather than covering lots more possibilities. So we're going to use the lower function that creates a variable text, which is the same text as it was in description, but just all in lowercase. Now, if we find this substring no parking within this text, we're going to return true. We're also going to look for another possibility. What if the permit says this project has 0 parking? We're also going to return true, true that this project doesn't have parking. If there is some other information about parking, we're going to, perhaps there's 1 or 20 parking spaces, we're going to return false, not a parking-free project. But we're also going to look at all other possibilities. Parking isn't even mentioned in this description. Then we're just going to return a null value. It's not correct to say this project has 0 parking spaces. It's correct to say we just don't know. There's missing data here. And now let's use the same pandas apply. So we're going to take the description column in our data frame. So each of these descriptions, we're going to pass this into our function in the variable which we're also calling description. And then we are going to pass this to our function, which is called no parking here. So basically the elements or the contents of each column for each row at a time, the description column is sent to this no parking function. And then we're going to store the result in a new column that we're going to call no parking. So we can see that we get some that have parking and some that just don't mention parking at all. So this is a brute force method of parsing text. We're basically looking for all of the different combinations of text that might indicate that there are no parking spaces, and then we're going to examine the string to see if any of them are in there. And we're going to see more sophisticated ways of analyzing text using natural language processing later in this course, but often this type of brute force approach is the simplest and most robust. You just need to look at your data and think all the ways that parking-free housing is conceptualized and how is it represented in this string. And I'm going to leave you with an exercise for yourself, a thought exercise. If you want to get the number of parking spaces for each project, what would be your next step? How might you do that? So right now we have a Boolean variable parking yes or no. But what if you want a variable that says there's 2 parking spaces, there's 20 parking spaces, there's something along those lines. So I'll leave you the takeaways that the simplest way to parse text is to look for a particular string that's contained within a longer string. Convert it to lowercase, you could also do uppercase. It's going to reduce the number of possibilities that you'll have to search for. And this in operator is very useful here. So we saw, like, is zero parking within, is it in this longer string? And that returns a Boolean value. Let's stop there. And in the next lecture, we're going to look at a more complex set of web scraping possibilities.